You've probably remembered that there is an equation for slope, which is y2 minus y1 over x2 minus x1. All that really means is that if you've got any 2 points between a line between 2 points, you can think of one of the x values as x1, the other as y1, and so this point would be x2 comma y2. And so if we're going to use this equation, we would take what we've decided is y2, so we'd have 1 minus 4 over x1 is 6 minus 1. What we get is negative 3 on top. I just found an error, hopefully you did too. x2 was 1, so these should be switched. This should be 1 minus 6 instead of 6 minus 1. So 1 take away 4 is negative 3, 1 take away 6 is negative 5. A negative divided by a negative is a positive 3 over 5. And you could also see that by just drawing in a run of 5 and a rise of 3. But sometimes this equation is very helpful. So now we know the slope is 3/5. But another handy thing we can do with this same equation, if we were to put m over 1 and now cross multiply, we would get m times the quantity x2 minus x1 and 1 times y2 minus y1, or y2 minus y1 equals m times the quantity x2 minus x1. This is called point slope form instead of intercept form. And it's very handy. Now I could come up with an equation. This equation allows me to know one point and the slope and come up with the equation of the line. This is what I mean. I'll arbitrarily take the point 1, 1 because it's going to be easy to use. So that means one of the x values is 1 and one of the y values is 1. Also, we just found the slope as 3/5. So now if I plug all this in, I have y minus 1 equals 3 over 5 times x minus 1. If I happen to use the other points instead, I would have had 3/5 x minus 6 and y minus 4. They look different, but they represent the same line. Let me show you why. If we distribute 3/5 to both terms, when I distribute, I have y minus 1 equals 3/5 x minus 3/5. Now I'll add this 1 to both sides, and 1 is in the form of, it's the same as 5/5. So I have y equals 3/5 x, 5/5 plus a negative 3/5 gives 2/5. That's the slope-intercept form of this equation. Now we'll do the same thing with the other equation we came up with, distributing y minus 4 equals 3/5 x. 3/5 times negative 6 becomes negative 18 over 5. Now we're going to add 4 to both sides. And here's where you have to do a little bit more math. We would need a common denominator, so I'm going to multiply the denominator by 5 and the numerator by 5. So really what I have is y equals 3/5 x minus 18/5 plus 20/5. Well, hopefully you can see that a negative 18 and a positive 20 is just going to give you 2/5. That's what we had before. In slope-intercept form, I still have y equals 3/5 x plus 2/5. All of these highlighted equations are correct and equivalent. One is not any better than the other. And so hopefully you can see how this point-slope form can be very helpful. We're going to be using it a lot in this class.